This is College Algebra, Math 1314, Section 2.3, Functions and Relations. Objective 1, determine whether a relation is a function. So this will have 4 parts. We will write a set of ordered pairs that defines the relation, write the domain of the relation, write the range of the relation, and determine if the relation defines y as a function of x. So part A just simply says write everything as an ordered pair. So this is what I'll do first. So as an ordered pair, you write the x and then the corresponding y. So the first order pair here will be Albany, comma 285. Then we will have Denver, 5,000 or comma 5,883. Then we will have Miami, comma 11. And then last but not least, we will have San Francisco, comma 11. And just write it in a set, and there is your order pairs. To write the domain, you would simply then just write the x values. I don't know how specific they get when it is not numerical. But I have seen on statistical analysis that they'll at least do it in alphabetical order, which I believe it's already done. So you start off with your set notation and then just list your domain, which again are just your x values, even though they might not be values in themselves. So you have Albany, Denver, Miami, and San Francisco. And then finish off the set notation. To do the part C, write the range. Again, you would just write the y values. So again, you start off with your set. Again, with values, I know you want to do from least to greatest, and you do not want to repeat a number. So I write 11, but I will not repeat 11. And then I would do 285, comma 5,883. Then finish off your set notation. And the last is determine if the relation defines y as a function of x. For this to be a function, every x value that you put in cannot repeat. So basically stating, um, do I have the word Albany more than once? Do I have the word Denver more than once? Do I have Miami more than once, or San Francisco more than once? Typically, if you have values, you look to see, does X repeat? Does it have two of the same values? In this case, we see that every city is represented one time, does not have multiple answers. Your Y can repeat all at once, but the X cannot. So for part D, the answer would be yes, this is a relation because every city has one singular output. Doesn't say like Albany's 285 and Albany's 11. That would be a no relation. All right, so that answers all 4 parts there. The next part, again, same 4 parts, but this time represented to you as a graph with some scatter plots on it. So all we'll do first is we will list the order pair. Best way to do it is go from left to right. So when I write my set of order pair, I see I'm at -2, comma 2. -1, comma 0, 0, comma -2, 1, comma 0, and 1, comma 2. That's best practice that I've always done is from left to right. I don't think there's a specific way as long as you have the correct X and Y with it. The next part is listing the domain, just like in the range. You want to go from least to greatest and do not want to repeat any numbers. So your domain here, your first X that got used was at -2, then -1, then at 0, and then at 1. At the X value 1, there was actually 2 of them, but I'm only going to write it one time and then complete the set. I then move on to part C, which is talking about the range. Again, I'm going to go from bottom to top, so it gives me the least to greatest number. And I see that my first number is at -2, and then I go to 0. There's 2 X values for the Y value at 0, but I'm only going to write it down one time. And then I see it happens at 2. And again, there are 2 X values that happen at Y equals 2, but I'm only going to write it one time. You can also look at the ordered pair as a key as well if you need some help with that. And then the last part is this a relation? Well, looking at your X values, was there an X value in which it had 2 outputs? And we can see that right here we have 1, 0 and 1, 2. This cannot happen. Every X value must have a unique output or a unique Y value to go with it. The Y value again can repeat as many times as it wants, but the X cannot. So this is not a relation. All right, in the next question, we're going to determine if the relation defines y as a function of x. Easiest way to do this is just use what we like to call the vertical line test. And so you can make as many random vertical lines that you want, but your goal is, can you make a vertical line where it crosses the blue part of the graph more than once? And the answer to that is no. So that means it passes the vertical line test. Therefore, this is a function. When you draw the vertical line, it can only touch the graph one time, and it does no matter which vertical line you want to take. All right, looking at this exact same graph, or sorry, another graph, not the exact same, but asking the same question, determine if this defines as a function. If I draw a vertical line here, I can say, hey, it only touched once, therefore it must be a function. But your goal is to try to prove yourself wrong. Is there a vertical line in which it will fail? And if I look right here with 2 solid dots, that tells me it hits here and here. So therefore it fails there, there, and there. So as long as it fails at least one time, that would mean this is not a function because it fails the vertical line test. All right, so looking at a different example. So if we determine if this is a function or not, looking at a diagram, there's a couple ways to analyze this. You could write this as coordinate points if you want it. This would be 5, -4, 6, -4, 7, -4, and 8, -4. So looking at an order pair, you can see that the X values never repeated. If you're looking at a mapping diagram, as long as there is not more than one arrow coming out of an X, you know X did not repeat. Again, the Y value can repeat as many times as it wants, but the X cannot. So this would be a function. All right, so another question like this, basically what you want to do here is you want to see, all right, if I plug in a value of X, will I just get one answer? Well, to answer that question, choose a point. It doesn't matter what you want to choose. Let's start off with like the value of 1. So if I let X equals 1, is there only one Y value that comes out of it? All right, so when I do this, I get 1 plus 3 squared plus y plus 4 squared equals 1. And you get 1 plus 3, which is 4 squared, plus y plus 4 squared equals 1. Then we get 16 plus y plus 4 squared equals 1. Subtract the 16 over. And so we get y plus 4 squared equals negative 15. And the way we get rid of a square is we take the square root of something. But don't forget that you must take a plus or minus. So this becomes y plus 4 equals plus or minus the square root of negative 15. Now, a couple things I want you to note here. Obviously, we can't take the square root of a negative. That would give us an imaginary answer. But what I want you to see in a pattern here is no matter what number I choose for x, when I go about solving for it, I'm going to have to take the square root of the result. And if I ever have to take the square root, I always get two answers. So anytime that your y value is as a squared, it is not going to be a function. This guy right here, if my memory serves me right, should make roughly like a circle or an oval or some shape. And you can see vertical line tests would fail there. But a good indicator is anytime you have a square on a y, we know the answer is going to be no as well, because you're going to have to take the square root to be able to solve for the y and then get more than one y value for every x value you plug in. All right, the second objective, we're going to apply function notation. So evaluate the function for the given value of x. Okay, I forgot to copy the functions. Let me go to number 38 real quick. Oh. All right, so our functions are going to be over here. We have f of x is equal to x squared plus 3x. We have g of x is equal to 1 over x. We have h of x, which is equal to 5. And we have k of x, which is equal to the square root of x plus 1. To evaluate these functions, you just determine which function you have. The different letters, the f, the g, the h, the k, is just a notation purposes. So I don't have to say, like, this is graph 1, this is graph 2, this is graph 3. I can just give it a name of f, g, h, or k, or any other letter I want. So when I ask the question, what's k of negative 2, I first pay attention to the k. And then that tells me I'm going to go to the k equation, which is the square root of x plus 1. And I'm going to plug that x value into just that equation. So when I do that, this gives me the square root of negative 2 plus 1. All right, so I'm only going to plug it into that one because it just said k of negative 2, which we see is the square root of negative 1, which at this point we know is I. So then we do k again. Again, we see k of negative 1. Pay attention to just the k. So this gives me the square root of negative 1 plus 1. And we see that's the square root of 0, which is 0. And then we're still dealing with just the k. Looks like we're doing with k on all of them. So this would again give me 0 plus 1, which is just the square root of 1, which is just 1. And then keeping the pattern going, we see this is just 1 plus 1, which is the square root of 2. That's as simplified as it can go. You leave it like that. Don't give me a decimal. And then we have 3 plus 1, which is the square root of 4, which is 2. All right. And so that's what you do. Determine on what letter you choose from. This is the one that we chose because that's what it told us to. All right. So again, this one says evaluate the function. So given the following f value from earlier, I'm going to use that same f. Let me go back. Let's see. So f again. So f of x was equal to x squared plus 3x. So if I'm looking for f of a, I'm literally just going to plug in a for every x value. And I mean every x value. So again, this a will replace this x and this x. So I then just get a squared, because again, I'm replacing the x with the a plus 3a, because I'm also replacing that x. Every x in the function will get replaced by whatever is inside that parentheses. And that's as far as you can go with it. All right. Then we get one like this where it says find and simplify f of x plus h. Let's see what number 58. All right. So again, what we're going to do here is we're going to take x plus h and we're going to replace all of my x values with that. So when you do that, again, this becomes f of x plus h. This right here is just notational purposes. And then when we write it out, it becomes -2. I see an x, so I open a set of parentheses. I'm going to substitute x plus h in for my x. I see a square, so I put the square on the outside. Plus 6. I see another x, so I open a set of parentheses, substitute in for x plus h, and then -3. All right, after that, we work it out. So we get -2. X plus h squared means x plus h times x plus h. And then I'm just going to write the rest of it down. Use a different color so it doesn't all blend in. And so what we're going to do now is we're going to distribute these two binomials before we distribute the -2. So that means I'm just going to drop down the -2. And I get x times x, which is x squared, x times h, which is x h times x, which is also x h or hx, same process, and then h times h, which is h squared. And then I come over here, and then you can go ahead and distribute if you would like. I'm just going to write it all out one more time. Because what I need to do is I need to combine like terms inside. So this will then give me x squared plus 2xh plus h squared. Again, I'm just going to write it all out. Again, if you wanted to skip some of these steps because you know the tricks, I'm okay with that. And so now I'm ready to take the -2 and distribute it. So I do get -2x squared, -4xh, -2h squared. Do the same thing with this 6, but only to the x and h, because the -3 is not in parentheses. So that'd be plus 6x plus 6h minus 3. And then our last and final step is to simply just combine like terms. Looking at it, I really don't think there is any like terms. I see an x squared, I see one singular xh, one singular h squared, just an x, just an h. Yeah, so therefore this would be your final result. That right there says for notational purposes. All right. All right, so then in objective 3, we're going to determine the x and y intercepts of functions defined by y equals f of x. So do note that f of x is just a fancy way of seeing y. We did some of this in 2.1, so if we can recall from that lecture video, we see that if I want the x-intercept, I'm going to let y equals 0, which remember y is just the fancy way of saying f of x. So even though it says k of x, I'm just going to let that be 0. And then I'm just going to solve. So that gives me 0 equals the absolute value of x plus 2, which then I subtract the 2, so that gives me negative 2 equals the absolute value of negative, or the negative absolute value of x. And then if I divide by that negative, I now get 2 equals the absolute value of x. And if we recall, there are two different answers that can equal a positive. You can either get 2 equals x or negative 2 equals x. So therefore, your x-intercept would just be negative 2 comma 0 and 2 comma 0. Again, I don't know if that's how the homework wants it or not. I would accept these two as a result if I was to ask the question on the test. All right, and then if we move on to the y-intercept, if you recall, that just simply meant that x is equal to 0. So this time I'm going to plug in 0. So therefore, and if you want, you can go ahead and change k of x to back to y so that you know that's what you're solving for. So that's going to be negative absolute value of 0 plus 2. We know that the absolute value of 0 is 0 because it's 0 numbers away from 0. And then negative 0 we know is just 0. So therefore 0 plus 2 is 2. If you want to skip some of those steps, that's completely okay. I just want you to see that complete thought process. So therefore your y-intercept would be 0 comma 2. Again, I pointed this out in the last video, but I want to point it out again. X-intercept has the number then 0 because the y value is what, 0. And on the y-intercept, it is 0 then comma the number because the x value is what's always 0. All right. In objective 4, we wanted to determine the domain and range of the function, kind of like what we did in objective 1. Given a graph, just give me the domain and range. So if I want the domain, which you can denote as just D, if it gives you a scatter plot, you want to start off with the curly brackets and then just go from least to greatest. So I see that I have a negative 4, negative 2, 0, 2, and 4. Again, going from least to greatest, never repeating any of your values. And then if I wanted the range, again, I'll go from bottom to top because that would be the least to greatest and not repeating. Again, because they're a scatter plot, we're going to put it as a set or list of numbers. So we see that we have negative 2, then we have 0, then we have 2, then we have 4, and then we have 6 and in the set. If it helps, you can always just write out the coordinates. So again, this would be negative 4, negative 2, negative 2, comma 0, 0, comma 2, 2, comma 4, and 4, comma 6. And then you can just look at the x and y values and write them out. All right. Again, let's determine the domain and range here. Now notice the difference here. This is a continuous line, no longer just scatter plots. So we will write it in interval notation when it's presented to us like this. One thing I wanted to note, again, remember the domain is the x values, but I like to go from left to right. I say I like to, it's the way you have to. So what you want to try to do is, can you think of the farthest left number the x value can go? Biggest mistake here, students will say -5 because that's the last number they see. However, that would be incorrect. This little arrow right here indicates that this function keeps on going. Therefore, it goes way beyond -5 and it actually just keeps on going. So that will actually be negative infinity. And when you're doing interval notation, recall that your infinity signs will always get a parentheses because you cannot equal something that just means a direction. The negative infinity just means it's just continuously going all the way to the left. All right, then you want to go, all right, what's the farthest right number? And hopefully you see that it goes all the way to 4 on the x-axis. So I go with a 4, and then I see that it's an open circle. So one thing I want you to remember is an open circle will always be parentheses, and a closed circle will always be a bracket. Parentheses means it leads up to that number but not including that number. the bracket actually includes that number. So this will be a parentheses for the domain. Again, range, remember that this means the Y. The way I like to do it is go from bottom to top. Once again, I tell students, all right, give me the bottom number of your Y value. They'll tell me it's -5 because that's the last number they see. But once again, that line infinitely going downwards tells me goes way beyond -5 and actually goes on to -infinity, in which you cannot equal it, so we use the parentheses. The next thing I'll ask the students is give me the top part, and a lot of times they'll tell me it's 3 because that's where the end point is. That is not the case. You want to go up to the farthest end of the graph, which in this case is actually at 4. And then the next debate goes, all right, but it's not open or closed. There's no dot there at all. What you need to realize is a solid line indicates a solid dot. So that means that this 4 will actually get a bracket. And there you go. There's your domain and range. Again, let's determine the domain and range once again. So start off with the domain. I have my X values. Again, I go from left to right. When I look at this though, I go left and I see that that arrow is infinitely going to the left side. And then I go to the right and I see that it's also infinitely going on the right side. So that tells me that the domain is every single number on the left and every single number on the right. So we indicate that with -infinity, comma, infinity, right there. You might also see this as a notation as well in the book, representing all real numbers. I don't know exactly which way your homework will take it. All right, and again, the range, remember it's the Y value going from bottom to top. So my bottom, again, I see these two arrows infinitely going down, so I definitely know it's -infinity going downwards. But then when I go to top, I see that the highest point on the graph is located right here, and that Y value is 2. And again, because it's a solid line, it represents a solid dot, so it will get a bracket. So there's your domain and range. Make sure I'm not missing nothing. Hold on. Okay. All right, so again, we want to write the domain in interval notation. Again, interval notation is just the parentheses and bracket. One big thing you just need to know about the type of graphs you get on 98 is that it is a reciprocal function. I believe I talked about this in the last video when talking about vertical asymptotes and horizontal asymptotes. Just a little bit in there. Reciprocal functions, again, when talking about the domain, is actually every real number that exists except for the number in which the denominator is 0, because you cannot equal 0 on the bottom of a fraction or the denominator. So all you have to do is figure out what can x not be, and hopefully when you see x minus 2, you go, all right, well, x cannot be 2. All right, so you're like, all right, so as long as x is, because I don't care about the numerator. Numerator can be anything, but for the x, the domain can't be 0 on the denominator. So now that I know it can't be 2, and the way I'm going to illustrate that for the domain, I'll start off with -infinity every single time, all the way up to that value that x cannot be, parentheses, because I can't include it, union, go back to that number again, not including it, so it's a parentheses, all the way to infinity. You're basically right here, you're just illustrating that it's every single number except the value of 2. Same concept here. You see x squared plus 2. If you need to set the equation up, do it. So you get x squared plus 2 cannot equal 0. Subtract 2 over, so x cannot equal -2. And then you go, but if I square it, I get an imaginary answer. When this happens, that means that x can actually be anything because you'll never get the value of 0 as the denominator. So in this case, it would be negative infinity to infinity. Right? Same process looking one here. We have x squared minus 2 cannot equal 0. Again, we're paying attention to the denominator only. I could care less about the numerator. Add 2 to both sides, so x squared cannot equal 2. And then I would take the square root, so x cannot equal plus or minus, because that's what happens when we take the square root of something, square root of 2. So that means x, to kind of let you see what's happening there, x cannot be negative square root of 2, and x cannot be positive square root of 2. So now you're going to have two unions going on. So you start off again always from negative infinity to the smallest value x cannot be, which in this case is negative square root of 2, union negative square root of 2, just like earlier, except now because there's two values that x cannot be, it will then go all the way to the next value, which in this case is positive square root of 2, and then you will do another union with that same number, finishing up going towards infinity. So again, what this is stating is that every single number except negative square root of 2 and square root of 2, but everything else it can be. So that's how you would illustrate the domain of reciprocal functions. All right, on this one here, it says write the domain in interval notation. So what you need to also know is that in a square root, you can't be less than 0. So all we want to do here is take whatever inside the square root, and we want to basically set it to greater than or equal to 0. It can equal 0, it just cannot be less than 0. So then we see that if we subtract 16, I get negative t is greater than or equal to negative 16. Divide by negative 1, so I get t, but because I'm dividing by negative 1, I must flip the inequality and get positive 16. So that tells me t must be less than or equal to 16. Again, if you struggle seeing that on how it should be written in interval notation, simply just graph it. Here's 16. It's got the line underneath it, so it would be a solid dot. And this kind of makes a little arrow indicating that I need a shade to the left. So my farthest left number there is negative infinity, all the way up to 16. Because it's solid dot, it gets a bracket. So there is your domain. Same process again. We have t minus 16. So this will be t minus 16 has to be greater than or equal to 0. So therefore, t must be greater than or equal to 0. Do the number line again if you need to. Here's 16, solid knot going to the right. So again, this kind of makes a little arrowhead pointing in that direction. So it'll be 16 with a bracket because it has a solid dot and a line underneath the inequality all the way to positive infinity. Now, when you mix the two, square roots and reciprocal functions, you have a lot of things going on. You have the square root. You have the square root in which it has to be greater than or equal to 0, but because it's on the denominator, that means that the square root can't even be 0 anymore because you cannot have 0 as the denominator. So what we'll do now is we'll take that 16 minus t and make it greater than 0. It's no longer greater than or equal to, it will just be greater than, because it has to be a positive, but now it can no longer be 0. So then we get negative t is greater than negative 16. And then again, if you divide both sides by negative 1, flipping the inequality in the process, we get t is less than 16. Again, if you have to write it all out with a number line, this time it'll be open, and I'll shade to the right because again, it makes an arrow key. So I see that it goes from negative infinity all the way to 16, but this time because it does not have a line underneath it and it's an open circle, it will be 16 with a parentheses and not a bracket. All right, so that's square roots. You already did reciprocals, and now you've done a mixture of both. All right, on this one here, we want to write the domain in interval notation. So, okay, a couple of things. You got to remember absolute values. Graphically, do these guys right here. Makes that little V looking thing. So if you have an absolute value straight up, nothing going on with it, the domain can be anything. I can literally plug whatever X value I want in that absolute value and get some type of answer coming out of it. So when it's just a straight up absolute value, your domain will be negative infinity to infinity because it can be whatever it wants. When you have an absolute value, on the bottom of a fraction, that's the denominator, same rule applies. You got to figure out what can A not be because I cannot have 0 on the bottom. So I will take the denominator and I will set it not equal to 0. So that makes it A minus the absolute value of A minus 2 cannot equal 0. So I'll subtract the A first, divide both sides by -1, and then set the two separate equations. So I get A minus, you get A minus 2 equals 8, and A minus 2 equals -8. If I add 2 over here, I get A equals 10, or technically, sorry, these are can'ts. And then A minus 2, so you add 2 over, A cannot equal -6. Right? So if you want to illustrate that, basically just like with the reciprocal functions, it can be every single number except these two numbers. So if you recall, the domain always starts from -infinity to the smallest value that it cannot be, which is -6, union -6, all the way to the next value it can't be, which in this case is 10, then union 10 on to infinity, indicating that can be every single thing except for the -6 and the 10. All right, so let's do that part C there. It's the same process. This guy right here cannot be cannot equal 0. I don't know why I wrote an A. That should be an 8. So I'll subtract 8, and I see that absolute value of A minus 2 cannot equal -8. So I'm just going to stop there. Again, going back to unit 1, we saw the absolute value can't be a negative. So therefore, we already know the absolute value won't be -8. It can't be -8. So therefore, there is no A value in which will make it 0 on the denominator. So in this case, that means that the domain will be -infinity to infinity because there's no number that the absolute value would make it -8. All right, the last objective, objective 5, we want to interpret a function graphically. So this one has a lot of parts. First, it wants you to determine what f of -2 is given this function. So if I ask you to find f of -2, what I'm basically stating is go to where the x value is -2 and then go up to the y value. That's my answer. So therefore, my answer is 1. So again, if I want to know what f of -2 is, I want to go to -2 on the x, go up to where it is on the graph, and then that is my y value. So the answer here is 1. All right, part B says determine f of 3. So same process. If I want to know what f of 3 is, all right, so I go to 3 right here. I go to f of 3 right here. I'm going to go up to where it is on my graph. I see that that's my point right there. And that means that the y value that goes with it is 3. So f of 3 is 3. All right. Part C says find all x values for which f of x equals 1. So this, again, you're looking for the x value, and this says f of x equals 1. So I'm basically, again, remember this is a fancy way of saying y. I want to know all the x values in which y equals -1. That is what that question is asking. So what I'll do now is I'll go to y equals -1, and I will draw a line going through it. Is there any value in which y equaled -1? And hopefully you saw that that black line went through none of the graphs. So f of x does not equal -1. So there are no x's. All right. Or no x value, no solution, however you want to say it. All right. And then I move on to part D, find all x values for which f of x is -4. So again, this is stating, give me all the x values in which y is -4. So I come back, I go, well, here's y is -4 right here. And so it looks like it's all of these x values from here to here. So in part D, all the x values would go from 0, because you're looking at the x, not the y. So you're looking at 0 with a bracket, since that's a solid dot, all the way to 2 with a parenthesis, since it's an open circle. So all of those x values gave us the value of -4 for the y. All right, then we go to E. It says determine the x-intercepts. So I'm going to look to see where it crosses the x-axis. And the only spot that I see is right here. So there's your coordinate. So that, again, that would be -1, 0, since y has to equal 0. Then we go up to F. F says determine the y-intercepts. So I go get my different colors so they're not blending. Y-intercept, so I'm looking to see where it crosses the y-axis. This guy is not a y-intercept because it's an open circle, but this guy down here is a y-intercept since they solid circle. So F would just be -0, -4. Again, to find the y-intercept, the x value has to be 0. Then we go up to G where it says determine the domain. All right, so I'm going to kind of erase all of our little pen strokes we got going on here so we don't get too lost. All right, that was supposed to be an F. Okay. So then on G, what's G? The domain. Okay, so the domain, remember, is left to right for the domain. So I go from the farthest left. I see that this arrow is indicating it goes infinitely in the left direction. So I'm going to go with -infinity. And then I'll follow it along. And people want to say, what, 0, there's no x value. But at 0, there is a x value. There's -4. So at 0, there is a y value that corresponds. Then students want to go, what, 2, it breaks. So there's no x value there. But at the value 2, there is a corresponding y value 2. So there is a x value there as well. So in this case, this will actually go from -infinity to infinity, meaning for every x value on this number line, there is some corresponding y value that I get an answer to. And that's basically what you're trying to do there. I'm going to assume that last question, part H, yep, determine the range, right? So range goes from bottom to top. Weird. I'll just rewrite it. So again, that's range, bottom to top. All right, so my very bottom of this graph, I see it's right at -4. But then that's it. It doesn't go further than that, doesn't go. There's a break right there. There's no other y value there. So we're going to put it in a curly bracket because it's just one singular number. And then we see another value of y at 0. So we'll say union 0. And then we see, is there any other breaks? A lot of people want to say at 1, but it's not. There's a y value that corresponds there. Next, people want to say, what about 2? Well, no, because there's a corresponding value there and there. So that means that there is a y value from 0 up that the x value would give. So in that case, that'd be 0 to infinity. All right. And I believe that concludes today's lecture. All right. And until next time.